Good afternoon, all. So, in today's class, we are going to see the introduction about deep learning and what are all the libraries we will be seeing in this deep learning concept. Okay, so before understanding the deep learning concept, first we should know like what is actually defined as artificial intelligence, and then how we are defining the machine learning, and how deep learning is being a part of machine learning. Okay, so when I say AI, artificial intelligence, it actually means the human intelligence. So, what does AI actually means? Terminate. Okay, so what we actually call it as AI. So we are trying to give some ability, so artificial intelligence to our mission. So where and all we will be using this? We'll be using this regarding the places like, just a minute. So in the field of reasoning, so main thing when we say a particular model or a machine is an AI based, it indirectly means that it can able to perform some reasoning. Okay. Then speech based and vision based. Okay. Then if I come to the machine learning part, so when we say it is a machine learning or what we actually call it as a machine learning, so we can say machine learning as a best tool. Okay, so best tool for what? For analyzing, understanding, and identifying the pattern. So that is what we have seen in previous classes, right? So identifying the pattern from the data which we are passing. So the main idea behind this machine learning is to train our computer to automate task that would be very impossible for an human. It can be either impossible or we can say like exhaustive task, like repeatedly you want to do like a machine based work or very systematic work, then you can convert them into a machine based or machine learning based model, okay, to reduce the human intervention. So generally we will coil the term by saying it as less human intervention. So you don't need to again and again need to train the model or feed the information like what to do, how to do. One time, one time you have created the model and you have trained means based on the past and the current data, it will try to train itself. Okay, then here when you use the data, it will be feeded in the form of algorithm. Okay, so what those algorithms will do, we have seen various algorithms, right? So it will try to find the relationship. If you are passing input means it will try to find the relationship between input and the output. Right. When the machine finishes learning, okay, you have done all the training process, and initially you will start with the cleaning, then you will train the model. Once the training has been completed, then you will try to make our model to predict the new data points. Okay, if I'm passing on new point means it has to predict which class it belongs to, or we can use it for regression type also, how much or how many, like what type of sales will happen. Those information we can collect it from the machine learning model. Okay, then what is deep learning? So what this deep learning will do? So in a simple term, if I want to say, means it is a mimic of human brain neuron. Okay, so it will try to mimic the network of neuron in a human brain. And we can also call deep learning as a subset of machine learning. Okay, so this is just a subset of machine learning. And we have already seen this type of diagram in this, where the data science part will come. For all three things we need the data, so data is must, and we will be using big data. So generally we call this term as big data. Okay, for all three things we need the big data part. And when it comes to deep learning, we need even more data to process and make the machine to learn when compared to the machine learning. Okay, in machine learning, very few data set also we have taken and trained and predicted the model, right? But if you are going for the deep learning means you will be giving huge amount of data to train your model for prediction and other purpose. Okay. Okay. First, let us see how human will learn. So how human will actually learn? By using the vision, right? As a first step, human will see some things. Okay, I'm saying, I'm showing one small kid some object which it has never seen before in his life. Okay, and I'm saying that child that this is so and so. For example, I'm showing the mobile phone to a child for the first time. So what that child will try to do? Okay, it will try to see the size of the mobile, color, and how you are handling everything. It will try to recognize it by using the eyes. Okay, then it will store it in our memory. Then next time, if I'm showing the same object, it can be any object. If I'm showing means it will try to recognize, okay, I have already seen this, my mother or father has trained this, this is a mobile phone. So mobile phone means this is how it will look like that you will try to recognize it, right? So as a first step, we can say like vision, then you can say it as memory or storage. Okay, then you'll recall it by recognizing the same image, right? So vision, brain, and then recognition happens. Whereas when you come to the machine learning, in machine learning part, how it will actually learns? It learns based on the data set we are passing, right? So data set will be passed as our input, then that will be trained to create one model. Once the model has been created, the next time when you are passing a new data point, it will try to recognize. Okay, whether same point or different point, it will try to recognize from the past trained data set. Okay, so this is how machine will learn, and this is how human will learn. And here, when I'm talking about the AI part or in the deep learning part, one advantage of using deep learning instead of machine learning is here some auto encoding we can able to perform. So auto encoding in the sense, if I'm passing two images means it will automatically try to extract the feature of those images. Okay, so Apple image if I'm passing means everything will be converted into pixels only, right? So it will try to convert each and every values into pixel, and each value will be stored in the form of data. So likewise, how many values you are passing for Apple means Apple data will be passed, and then banana data you will be passing in similar way. It can be directly passed as an image, or you can pass it as a CSV file putting the value of each pixel. So anyways it is going to convert, even if you are passing image, video, text, everything will be converted into form of zeros and ones and in the form of pixels only, right? Then that will be trained by our model. Then next time when you are passing a new image which is closer to any image you have trained already, okay, whether you are passing an apple image or banana image, it has to predict what image it is without any much training given by the user. Okay, you will be passing the value, and it will automatically try to extract the feature from those inputs, and then it will try to predict the value for the new input which you are passing. Okay, and this deep learning is also a very powerful tool in making a prediction as well as actionable results. Okay, here also pattern extraction we can say. It will try to extract the pattern from the given input. Pattern extraction or pattern discovery we can say. And for training this model, as I have told, we need big data. Okay, so you are already started studying about big data, right? So in that, how to store the data in Hadoop or other Apache Spark, like that you will be studying. Then using that, how to extract the information from those big data, those things you will be studying. When combining both the things, okay, this is how the organization will work. So they will be having huge amount of data. Each second it will be generated. Whenever one transaction is happening in a small organization to a big organization, everything is a data. So those data has to be processed and it has to be converted to some useful information to gain some insight. So with that insight, what we can do, we can predict the sales, right? We can predict the sales, or we can use it for productivity. How can we increase the productivity? Then what else we can do? We can also use it for management, and then for new innovation also based on the user interest and usage. Okay, and the study has been saying that deep learning, okay, when I'm comparing deep learning and machine learning, deep learning is 41 percentage more accurate in the field of image classification. If I take image classification means 41 percentage more than the ML part. Okay, when it come to what we can say, face recognition. So facial recognition, if you come means when compared to the machine learning, it is 27 percentage. Okay, approximate value only, not exact value. So it will be more accurate. And when it come to the voice recognition, more than 25 percentage of time, the deep learning is predicting more accurately than compared to the machine learning. Okay, only disadvantage if you say means you need to feed huge amount of data to our model. Okay. Diagnosis of disease in health sector. That can also we can say, like we have to pass various disease related information to our AI, and then based on that, when you are passing a new X-ray or the scan report, it has to say what type of disease the person is having, or any disability is there. Everything it can be able to predict, and also it can prescribe the medicine also to some extent, right? If it has predicted the person is having the particular disease or not. Then, so as I told, it would be having automatic feature extraction. Then finally, it has to say it is an apple based on its previous record. Then, do we really need GPU? So when I say GPU means it is graphical processing unit. Okay. So before going to the GPU, we should know what is CPU. So generally, we are using the CPU only to process all the data, right? And for the machine learning concept, we have never gone to the GPU. So we don't need any graphical processing unit to process our data in machine learning. Okay, but in the CPU, we are having some disadvantage also, right? To overcome those disadvantage only, we are going for the GPU concept. So, what are the disadvantages or challenges which we will be facing if you are using only CPU is less bandwidth. You'll be having very less bandwidth and latency will be there, and if you are dealing with some real-time application, okay, real-time application means at a time 1000 or 10,000 users can also be access a particular website or any resources at a single point of time. So that time the server also should not be crashed, and the resources also should be utilized in a proper way. Okay, there should not be any lag in the process means, then with the help of CPU, it is not possible. You have to move to the GPU, so graphical processing unit. So as an hardware, you have to install this into your system, or in the server you will be installing. So using that GPU, it is a dedicated chip for processing the data. Suppose you are dealing with some image, okay, high quality images if you have taken, or video based processing if you are doing means, that time if CPU is taking weeks to complete the process means, with the help of GPU, we can complete the same process within some hours. Okay, so that is the one of the reason that we go for CPU to GPU. Okay, so when I say graphical processing unit means, so obviously what are all the challenges we have told in the GPU part, that will become the advantage. Like here, we will be having high bandwidth, and then thread parallelism. So parallel it will try to execute the process, as well as some optimization also we can able to do. Okay. So in simple term, it can train more number of data in a short period of time, and it is very better for real-time AI based application. So where and all, if you are going to use an AI based application in real time, it is best to go with the GPU instead of relying with the CPU. Okay. Then where and all we can actually use this deep learning concept. So just because the deep learning is a booming technology, it doesn't mean that everywhere you have to force fit this particular model. Okay, only for things which we actually need them, we can use this deep learning. Otherwise, we can go for the traditional method itself. Uh, GPU can be automated also. Okay, whenever there is a need for it, we can specify, or it will be an automated task. Specifically, you want to use GPU means we have to specify in the Python code also. Okay, through GPU, you want to perform this. in the machine, if it is not available, what will happen is, for some applications it will check whether GPU is present in your system or not. If not present means it will try to run in the default CPU. If already present means it will utilize the resources from them. Okay. As we all know that every system will not have a GPU support, right? So to overcome this, what we can do is, in Google Colab, they provide some GPU support also. You can enable that support means, whenever there's a need for a GPU, it will automatically utilize the GPU resources from them. That also I will show how to enable the GPU, but it will be a limited resources, and you cannot keep the GPU turned on and use it for long time. Okay, after some point of time, if it is kept idle means, it will say your GPU has not has been utilized, whether you want to convert to CPU or you want to still maintain the GPU or not. Okay, okay, okay. Let's come back to the topic. So, what deep learning is actually good for, which means where and all we can use the deep learning concept. Suppose you are having a problems with a long set of rules. So each time if you want to define some rules, for a simple example, see, for humans, few things may look simple, but to make the machine to do the same task will be very difficult. Whereas in the other case, human will feel few things to do it very difficult, whereas the machine can able to do it in a fraction of second. For example, mathematical or any arithmetic calculation if you take means, a machine can able to perform very fast. Even searching a data from the document. Everything is a piece of cake for a machine. Whereas when it comes to the human, it will be very hard to search those information. Vice versa, if you take means, for human, maybe it is very easier to train a child, actual child, to differentiate between an apple and an orange. I mean, apple, orange, banana, whatever fruit is there, we can able to do. Whereas for a machine, if I want to write a code means it is possible. I cannot write, right? I cannot say this is the exact size and shape of an apple and color of an apple. No, the shape, color, everything it will change time to time, or some places the fruit size will be big and another places it will be small. Even if you take apple also, it will be in a red color, green color. Okay, some rotten apple is there means it will be having some mixed color. So for each and every scenario, we cannot able to write a code, right? So those cases, what we can do, we can go for the deep learning for auto extraction of feature. Okay, so whenever the traditional approach fails, we will go for the machine learning or the deep learning concept. That is first thing. Then continuously changing environments. So continuously changing environment means each time it's a like kind of reinforcement learning, right? In real time, if you take means, the chess game, the Go game and all, if you there means each time the user will take a different move. Okay, even in video game also you can take it as an example. We cannot say this is the exact move the person is going to take, right? Each time you will be playing in a different environment, and each time you will take a different decision. So based on your decision, I have to change the next move, right? So those and all some example of changing environment. So those type of changing environment, we can go for the deep learning concept. Okay, then discovering insight within large collection of data. Okay, if you are having a huge amount of data, it will be even harder to process the data in simple Excel. Okay, we can able to perform lot of operation in Excel itself, but still, to make the process more automated and easier to perform, we may be moving from normal Excel concept to a machine learning model. Okay, so that each time you don't need to manually do all the processes. One time you have trained means, next time if you are passing on new data set means, it has to perform the steps by itself. So we have to discovering the insight within the large collection of data. So can you imagine like trying the handcraft rules for what different kinds of food look like. Okay, here they have given like different how different types of food will actually look like. So we cannot write a definition, right? This is how the food also should look like. So a same food may look different in different places also. The cooking style, the presentation, everything is going to change, right? So from that, if you want to gather any insight, means we can go for the machine learning or deep learning concept. Okay. No, it will not like ask you. It will search whether you are having a GPU or not. Okay. Accordingly, how we have programmed your code. Okay. So if GPU is not present, it will give you some warning. Okay, it will just give you warning and it will start running in your CPU. But the difference is the lag will be there. As you see some latency I have told, right? Suppose you are seeing an image based or what to say, face detection like that is there, means you will see some lag, like you will see some pause in the video streaming. Okay, so that time it is we can understand that it is working in the CPU, so the detection will not be that much accurate. For example, hand gesture recognition application is there. Okay, and if you see the hand gesture means they will be moving in a very fast space. Okay, that time if it is accessing the data in a very slow phase means it cannot able to understand each character. If it is not able to understand means it cannot convert it into a proper sentence, right? Within a blink of eye, if you are changing three gesture, it will detect only one gesture means it cannot form a proper sentence, right? So those cases we need GPU process to make our application run faster. Otherwise it will take some time to process. Slowly we have to do the either video or image based anything, it will run accordingly. No, if see, suppose it can be completed with the help of CPU itself, and you are saying you are having GPU means it is not going to use the GPU that much. It will automatically take the CPU only. Okay, but it will check. Suppose you are having GPU and you are trying to force it by using CPU also, it will not. You will not see that much difference. Whereas when you are really need for a GPU, so what will happen? Work will be allocated accordingly. So it will try to utilize the CPU also as well as the need for the GPU also will be satisfied at the same time. Okay, I will show it in the Google Colab so that you will know. Right now, I'm not going to run any program by using the GPU, but later on, when you go for the machine learning or anything, means I mean, sorry, not machine learning, image-based classification or high uh, processing you are going to use means that time you will know whether we need a GPU or not. Okay. Okay. So we have seen where and all we can use deep learning. Now let us see where and all deep learning is actually not needed. Okay, you can go with the normal traditional method itself. So those are some of the places like when you need explanatory, which means it has predicted correctly. Okay, for example, I have told you, right? I have passed the previous scan report and other things, okay, to my model, and then I'm passing one new scan report to my model and I'm asking whether this person is having cancer or not. Okay, cancer data set I have passed and I'm asking whether the person is having cancer or not. It will either going to say yes, this person is having cancer, or this person is not having cancer. Or if you're doing it as a regression base means what it can say, okay, there is a 60% possibility that he may get cancer, or there is 90% possibility that he will not get a cancer. Like that, either classification based or regression based, we can get some output. But can we make a machine to say, okay, these are the things I have checked, so because of this only I'm saying this person is having cancer, or this person may not have cancer, like that? Can a machine can explain to you? No, right? Whereas when a doctor can explain, okay, these are the reasons that you are having a cancer, or there is a possibility that mm, you may get a cancer, he can give some explanation to you, and he can give some solution also accordingly, whereas machine cannot do that part. So there we don't need to rely on deep learning. Okay, what we can do is we can simply pass our values to the model, and we can say, okay, whether um, the person is having cancer or not. That will be predicted by our model. Then, as a doctor, okay, as a specialist, he will be giving you the explanation. Okay, I have cross-checked with the data set and the model. So it is predicted that you are having cancer, and these are the reasons it has predicted you are having cancer, and these are the possible solution you can follow to overcome this or cure this particular disease. It can be any disease. So there, the deep learning will not be very much effective. Then, when the traditional approach is a better option, okay, simply you can perform small operations, okay, with the help of human intervention, means instead of going for that, if you are creating some model, okay, it will be a time uh, s- I mean time and money consumption. Okay, you will be unnecessarily spending lot of time in training the model, as well as if you are spending lot of time means for storing the data and processing, obviously you will be spending lot of money also, right? For GPU separately you have to buy some hardware, and for storage, if the local storage is not enough means you have to store it in the cloud, then you have to pay for that cloud storage. So those are unnecessary expenditure for the model. Right. And even after doing all these things, the prediction is not that much accurate when compared to the traditional method, means then there is no use of going for the deep learning model. We can still rely on the what a traditional approach itself. Then when errors are unacceptable. Okay, for assumption we have seen so far, right? 70% accuracy it is predicting, 85% it is predicting, or even some cases we have got more than 95 to no 97 or 98% accuracy. But we have seen about the confusion matrix example also, right? If a person is not having cancer, and if our model is saying he is having cancer, that is also a risk, right? Why? Because a person is not having cancer, but unnecessarily he will be spending money on medica medicines, right? As thinking that he got a cancer or any disease. So that is a wrong thing. Okay, so it is one type of error. Another type of error which is unacceptable is the person is having a cancer, but our model is saying he is not having a cancer. So what will happen? The stage of cancer will be increased, so it will lead to the its death. Okay, suppose it is a non-spreadable disease, means no problem. What if it is a spreadable disease like COVID or something, and you have predicted the person is not having COVID? Then what will happen? He will be spreading the disease to some other persons also, right? So those type of error we call it as unacceptable error. So in those scenario, we will be going for the traditional method instead of relying on the deep learning model. Okay. Then when you don't have much data, obviously if you are not collecting any data from the user point of view, or you are not having any data to process, okay, it's like orally you are communicating something and doing the transaction. Okay, previously and all that is how will happen, right? If you go to before supermarket, there will be some market will be there. In that you will go and purchase all the product. So they will not note down who has purchased, what they have purchased, and how much they have purchased. Those data they will not have, right? So they cannot come and ask to an machine learning engineer, I mean ML engineer or DL engineer, that okay, I want to predict how much sales will happen in my store. Is that possible? No. Why? Because I don't have any track record of who has purchased, what has purchased, how much they have purchased. Those information will not going to be there. Only thing they will have is this much product I have bought and this much product they have sold and this got expired and this the profit I have earned. Like that information only I will be having. Okay. Those information is not that much sufficient to train our deep learning means then we should not go for our deep learning concept. So, okay, we should rely on the traditional method itself. Then, what are all the difference between machine learning and deep learning? Okay, so let me, so machine learning and then I'm taking the deep learning or I will divide it into two of. So, first thing is data. Okay, when I take the data, when it come to the machine learning, it will perform uh, in an excellent, it will give an excellent performance on small and medium data. Okay, small and medium data is enough for the machine learning. Whereas when it come to the deep learning, we should have big data set. Big data set for better performance. Small and medium data set for excellent performance. When it come to the hardware dependency, so when it come to hardware, the machine learning algorithm will work in low-end machines also. Okay, till now we have seen so many algorithms, right? So nowhere I have used any GPU, right? It is worked in the normal processing speed itself. So it will work in the low-end machines, whereas it requires powerful machine. Okay, preferably as we have seen, it requires CPU, I mean GPU. Okay, to perform some complex matrix multiplication. Okay, so here we need we can say dedicated GPU. Okay, then feature engineering. Okay, suppose you want to perform some feature engineering means what we need to in the machine learning concept. Feature engineering means feature extraction, all other things will be included in the feature engineering itself. Okay, we need to understand the features and then we have to represent the data into our machine learning model. Okay, so we need to understand the feature. Then only we can feed the data into our model. Whereas when it comes to the deep learning, no need to understand the best feature to represent the data. Okay, we can actually pass the data as it is with the help of the auto encoding method and feature extracting. It will automatically predict the classes. Okay, so no need to understand the best features. Okay, then when it comes to the execution time, so how much time it will take to complete its execution. So it may vary from few minutes to hours. Even in the R period, you might have seen it might have taken 3 to 5 minutes to complete the iteration process itself. So like that, it may take few minutes to hours, whereas when it come to the machine learning, it may even take weeks, even takes weeks to complete the process. Hmm. Deep learning will take more time if you are not using GPU. Okay. If the same thing, if you are putting in the ML means that will take, you know, here it is taking weeks means it may take more number of weeks also. Generally, like data set will be very high, okay, in deep learning. So the processing also will take lot of time if you are putting in the normal CPU. If you're going for the GPU means even the process which can be completed in weeks can be completed in hours. Okay. Then here algorithms if you see means what are the algorithms you have seen? So we have seen various algorithms like logical linear based algorithm we have seen, and then decision tree based we have seen so many we have actually seen. Then SVM, what else? Linear logistic, and then decision tree, random forest, SVM, KNN. Okay, and when it come to unsupervised learning, we have seen K-means, hierarchical clustering, and then RPR based learning. So various things, various algorithms are actually there in machine learning. Okay, whereas it is very what to say, here we will be classifying into different categories, but we cannot exactly say these algorithms we are using. Okay, internally it will be using a neural network or neurons we can say. We'll be having neural network and activation function. Okay, and then we can say some epoch counts we'll be having. Okay, loss we will check. So these are the things we will be checking. Separate algorithm like that not there. Neural network, based on the neural network only, it will try to predict everything. Okay, inside the neural network, we will use the activation function. Various activation functions we are having. So based on the different activation perform, the output will differ accordingly. Okay. So activation function and all we'll be seeing in the upcoming class. Okay, what all the activation functions are actually there. Then simply in a simple term, if I want to differentiate a machine learning, okay, this is a machine learning based model, or this is a deep learning based model. Is machine by seeing this diagram itself, we will know machine learning or structured data. Okay, even if it is a supervised or unsupervised, we have used what a structured data only to train our model. Correct. Whereas when I come to the deep learning, it will be completely going to be in a form of unstructured data. So unstructured data means it can be in the form of text based or image based or voice based. So these data are not going to have any proper structure. We cannot say this many words only is going to be there. Okay, these are the classification. Classification also we can define, but still it is like a unstructured only, right? From this I'm asking, okay, whether this is a normal tweet or a, a sensitive tweet or in a bad tweet, good tweet like that. I can able to classify, but as a deep learning, we cannot say it is a structured one, right? One person will be giving it in 10 lines means another person is going to give it in uh, 20 or different number of lines. So that time we cannot rely on the machine learning. We cannot create a structure for these type of datas. Okay, so those type of data will be handled by our deep learning model. Pixel values, everything. See, end of the day, machine can understand. Okay, it is not about machine learning or deep learning. Machine can understand only 0 or 1. 0 means off, 1 means on. So all this data is there, right? Will be converted. Each value will have some ASCII code. Okay, nowadays we are using that UTF-8 format, okay, encoding format we will say. So using this, different languages also can be processed. Okay, not only if I take ASCII means for only English we are having the ASCII code. Whereas when I go for this UTF-8 encoding method means for all language it will support. They will having some unique encoding value, so that value it will convert. Okay, text will be text or audio, image, everything will be converted into that value, and those values will be trained, will be converted into the machine learning, machine understandable value. Then based on that it will perform the training. Okay, like how in the machine learning what we will do, we are getting 0 means we will create some condition, right? If the result is equal to 0, then this person will get greater than 50k salary, else the person will get uh, less than 50k. Like that we are making some assumption, right? Similarly here also it will perform accordingly. Image means image is nothing but a pixel. Okay, number of pixels. So video means what? Number of image frames. Okay, so like that it will try to process the data. Okay, so voice also they will be having for each frequency some based on the sampling method and all, it will perform the operation. Okay, so some of the use cases are recommendation system. Okay, or we can say recommendation engine in Netflix, YouTube. Okay, or even in the e-commerce websites and all, if you have seen means this type of recommendation engine is playing a major role. So recommendation means when you are logging into your particular account, it, your interface will be different. If you are not logging in means your user interface is going to be different. So how it is varying for person to person based on their own interest, based on their past watch history, everything it will take it into consideration, and accordingly it will provide you the recommendation, suggestion. So those are happening. Okay, so example like YouTube, Netflix, or any type of entertainment website or e-commerce website. Okay, then in case of translation, if you want to translate from one language to another language, so even it can be a text-based or voice-based translation, those are also nowadays become much possible with the help of deep learning. If you have seen 5 years, okay, before 5 years, if you have seen the same Google translation, if I want to translate something, for example, my name is, like I'm giving Ignesh means um, what it will, how it will translate. My means if I want to translate in Tamil or any other language. My means whatever the equivalent Tamil word is there, that will be placed here. Then for the name, um, like likewise, it will be character wise character. It will try to convert, and it will not give any meaningful sentence because grammar will change for language to language, right? But nowadays, if you are seeing means it is giving in a proper sentence format with the proper grammar, everything it is giving. So all become possible because of this deep learning only. Okay, we have trained with a lot of information from the user, So wherever it makes a mistake, we will try to correct those mistakes. We will again and again retrain our model. Then finally we are getting some best result out of it. Then computer vision based. Suppose one object is moving, like object direction, we can make. What else we can make? Like face direction, we can make. Okay, or uh, movement direction, or posture. Lot of things we can able to make our model to detect, or we can make a number plate. So number plate prediction also one of the applications, we can say real time application. So if I pass a image which containing the number plate, means it will predict and say, okay, this is the numbers which are present in the number plate, this is the color of the car or any vehicle. Those information it will say. Where we can actually use it, suppose if a particular person is violating the rules, okay, in the red light signal, they have moved, okay, so automatically what it will do, everywhere nowadays, in Chennai also they are placing cameras. So those camera will recognize the number plate. So whoever is not following the rules, okay, their number plate will be captured, and they will have some registered mobile number, right? Registered mobile number will be there. For that mobile number, some account number will be linked. So directly it will send the what fine bill to the particular person. So next time if a person is going for any renewal or any case, means that time it will show, okay, these are the days you have violated the rule, and what are all the violation you have done, and what is the fine amount you want to pay, and what is the pending amount you have not yet paid. Like that we can make our machine learning or deep learning model to perform. Okay, and then we are having natural language processing. So natural language processing means again text based, we can say, whether we can find whether the given mail is a spam mail or a not spam mail. Or sentiment based means based on the Twitter data, what we can do is whether a person has tweeted normal data, I mean good news or bad news or neutral information, like that we can check. Or if you're taking Grammarly, okay, Grammarly is there, right? In that if you're typing something, means it is giving you a suggestion, right? These words you can use instead of traditional words. And then what else? If you're typing on complete paragraph, means it will say what type, how the paragraph, grammar and other things. This paragraph is looking good, encouraging, motivational. Like that, it will be giving some suggestion also. So those things are possible with the help of natural language processing. And to perform this natural language processing, we are having various libraries also. So any doubts is there till here? Okay. Then let us see what are all the some of the libraries we will be using for the deep learning. Okay. The first thing is TensorFlow. Okay, it is one of the famous what we can say library or framework. We can actually call it as a framework also, which we are using nowadays, and upcoming class also I will be using the TensorFlow version 2.0. Okay, in TensorFlow also we are having version 1. Like some version is there, latest version, and then 2.0 is there. So latest version we will be using 2.0 only. Okay, 2.0 means 2 point some will value will be there. Version 2, that alone you just remember. When it compared to the version 1 and version 2 will be very easier. The syntax wise lot of changes they have made. Okay, whereas in version 1.2 for simple calculation also we have to perform lot of operation. 2 version 2 is the latest. In that various update will be there. 2 point some 13, some 16 something will be there. I'm not sure about the exact version, but 2 point it will start. Like how in the Python we are saying 3.7, 3.8, 3.9, like that it will be. Okay. The advantage of using this TensorFlow is by default, I mean previously in version 1.0 we had Keras API. Okay. But in TensorFlow 2.0, Keras has been integrated inside the TensorFlow itself. Okay, and this TensorFlow is a Google open source project. Okay, and then this TensorFlow has been developed with a programming language called C++. Okay, using the C++ only they have developed this. And where and all, I mean, they are using this TensorFlow. Which are the organizations are using this TensorFlow is Airbus. Okay, and then in Google also they are using some amount. Okay, because Google only developed this, right? So they are using, IBM is using, okay, this TensorFlow framework. And another advantage of using this TensorFlow is it supports multiple GPU. Okay, distributed computing on multiple GPUs possible backend Keras. So it is working based on the backend of Keras. Okay, then the next library is Keras. So since it has been integrated in TensorFlow itself, we will not be studying about the Keras separately. Okay, inside the each time when you are trying to give any neural network, we will be representing the Keras only. Okay, it is like TensorFlow dot Keras. Inside the Keras only, we will be having all the methods. Okay, so the advantage of this particular Keras is it is completely developed using the Python. Okay, it is developed using the Python. But here the problem is it does not support multiple GPU, but it will perform better. So that is why what they did is they have integrated with the Keras, I mean the TensorFlow. Okay, then TensorFlow is by default having the multiple GPU, so the disadvantage has been overcome by this particular framework. Okay, then even this TensorFlow also used by, sorry, Keras has been used by the Netflix and then Google, Netflix, and Uber and all using this Keras model. Then another one framework is, okay, Thano is there. Then MX Net is there. Okay, MS Net is somewhat older also we can say, and we can mainly use it for. Okay, this is also an open source project only. And here they have used various languages, okay, like C++ they have used, and Julia one language is there they use, then Python, R. So many language has been integrated to develop this MXNet, and this also supports both CPU as well as GPU. Okay, then Cafe. So again, this is also another deep learning framework. So when I say framework means, what is the difference between library and a framework? If you ask means, in a library you will be having some collection of similar functions. Means in a framework you will be having a collection of libraries. Okay, various libraries you will be having inside one umbrella. If you are saying means that we can call it as TensorFlow. Sorry, that we can call it as framework. Okay, and in the TensorFlow, another advantage is lot of algorithms will be pre-trained. Pre-trained algorithms also will be available in TensorFlow. So that is why we will be using TensorFlow more than other frameworks. Okay. Then this NumPy and SciPy are some basic library. I have previously told, right, this NumPy and all, every framework if you take means there will be a NumPy version will be there. Okay, using that NumPy only they might have developed these type of frameworks. So similarly, similar priority you will get it for SciPy also. If you want to perform some scientific calculation, then you will be go for the SciPy method. So numerical Python means NumPy. So if you are performing some advanced scientific calculation, then we will go for the SciPy library. Okay. Then we are having torch. We usually call it as PyTorch. Okay. So this is one of the oldest ML and DL library. Okay. And it supports CUDA. CUDA means Compute Uniform Device Architecture. Okay. It is mainly used for the parallel computation. Okay. Parallelly it will try to run all the processes, and it will mainly use for supervised learning and CNN type of model. So CNN, if I say means what we can say, image based. Okay, we will be dividing into different algorithms that also I will show. Okay, I think okay. Actually, three things is there. ANN we will say, RNN we will say, and then CNN. Okay, so ANN if I say means artificial neural network, RNN if I say means recurrent neural network, and CNN means convolutional neural network. So according to the problem, we'll be using different methods. So if you are dealing with a numerical type of problem means you will go with the ANN. Suppose if you are dealing with the text based any classification or any natural language processing means we will go for the RNN method. And if you are dealing with the image, video, those type of data means we will be going for the CNN method. Okay, so for this CNN model and all, this PyTorch will be very helpful. Okay, then so these are the libraries we have. You have to install it. Okay, till now I have told in the Jupyter Notebook you will be having all the libraries which we are using right now. For example, NumPy, Panda, Matplotlib, those are already available by default, and I have also showed you how to install it. But whereas when it come to the TensorFlow and other libraries, it will not be pre-installed. You have to install it in your system. Okay, so let me install it and show it to you. At the same time, I will show how to use the Google Colab also. Okay, so this is the command pip install. You have to give TensorFlow. Okay, so it will install the latest version, and these are the things it will be installed along with this TensorFlow. So TensorFlow is a framework I told, right? So in this framework, you will be having these many libraries. So this is a older version, screenshot. If you go means you will be having some updated libraries. See, you're having the NumPy is there, and then so many. See, Keras pre-processing is there. Likewise, various tensor board is there. So these and all some what to say GUI based visualization is there. Okay, these are some of the libraries which you are seeing here. Likewise, various libraries will be installed. Okay, so first step is you have to install the TensorFlow. Then Keras also you can install. And one thing we need to check is both the version of TensorFlow and Keras should be same. Okay, if mismatch is there means you will be getting some error also. Okay, so let me show that. So I have already installed. Maybe I will check. So directly in the Jupyter Notebook itself, we can install. Okay. Otherwise, if you want to install through the terminal means, what you have to do? You have to uh, enter into the Jupyter Notebook, like virtual environment. You should be there. then only you have to install it. Okay, so let me install in the Jupyter Notebook itself. So you have to give. Okay, see 600 MB of data is there. So you should be having you know mobile data or any broadband data before you are installing this TensorFlow. So if you feel difficult to use TensorFlow in the Jupyter Notebook means, then you can directly go to the Google Colab. Okay, in Google Colab by default you will be having this TensorFlow. Or if you are installing one time means you can use it later on. Okay, and some graphical support also available that I will show you in this tomorrow's class. Okay. So based on your internet speed, it will take some time to complete the process. Recording stopped. No, recording is still continue only. Okay. See, it has been completed. Pip install TensorFlow. Okay. Let me restart my kernel. See, it is showing like requirement already satisfied. So no need to install the Keras. It is showing like this. Okay. So to check the version, so I'm just going to import tensor plus tf. Okay. So the version is 2.10.0 that has been installed into my system. So these are some warnings only. Maybe I'm not having some GPU support and other things. So that's why it is showing like this. Okay, you can ignore this warnings and all. Okay. So I want you all to install this TensorFlow, okay, and just check whether Keras also installed along with the TensorFlow. If not, means you can manually install them also. Okay, so I'm stopping here for today's class. Okay, so in tomorrow's class, we will be seeing about the remaining concept in the deep learning, like how the neural network will work and what are all the activation functions are present and how to use them. Those things we will see. So if you have no any doubts means I will wind up this session. Mm, GPUs, in some cases we may need GPU also, Saurabh. Other than that, it is not mandatory. It depends upon the application. Okay, if you are creating a project and that project it's a real time means a live webcam feed if you are taking that time and all, if GPU is there means it will perform very better. Otherwise, you'll be having a lot of lag. Or even in GPU also, if you are having good processor only, it will process it very faster. Otherwise, it will take lot of time for computing itself. Okay, we are not that much level we are not going to use, but I will show okay one or two project image classification and all. Some GPU support is there means it will complete the task faster. Okay, okay, thank you all. 1K, already 1 hour, I mean, lot of time has gone. If possible, tomorrow you can explain your project. Okay. In the beginning itself, you can explain.